symmetry, which is we're saying this is the assumption of repeated measures ANOVA. So the way how we do this in mixed model, I put prac mixed data equals data name, which is long late. Remember, we're gonna work with long from here and on. So now equal long late.
Long late or late long?
Late long. So now class statement to do what? Before we put for class statement treatment, right?
Yes.
Now we have something else. ID or subject or MRNs is how you identify your patient, right? So you need to put that ID, group, and time itself, which is in our example of late is what? Week, right? So now this class statement should be there and should include what?
ID, group, and time.
The treatment and the time or week, right? Now the model. This is just similar to linear regressions now. The response, your response, remember the late that we created? The numerical equal what? Equal the treatment or the group and the time separately. These are the main effect now. And their interaction. The interaction between the treatment and the time, and this is what I'm interested in, right? Remember, I'm interested in to see differences of treatment over time in late. So now, once we're done with this statement, repeated, this is a SAS keyword for what? We're familiar with repeated statement, right? So repeated, that means my data involve replicate and different reading over time. Then I have to give it the time variable, which is for me in late this week, right? Slash option, the subject, this is a SAS keyword. This is where I'm going to use the ID. So the subject equal ID. If it's MRN, then I say equal MRN. But in my example, I'm going to say ID. The type for what? The type of variance covariance structures. This is also SAS keyword. You have to specify that, which is you requesting what? The compound symmetry. This is R core for just correlation. This is an options you may not need. Just R core. It's okay if you're gonna put that and then run. So what this will give you?
Compound symmetry.
This will give you a repeated measures ANOVA, assuming that you have a complete data. If you don't have a complete data, you will see differences between what given a mix and what is given you a GLM for repeated measures. You understand this? Remember, this is the compound symmetry. What is the assumption of compound symmetry? That the variance covariance structures are equal over time, right?
Okay, هذه
ANOVA, repeated measures ANOVA. So now what we're saying here, you're trying to fit here repeated measures ANOVA with the compound symmetry, and if you have no missing data, you will be able to produce the same result as you produce in ANOVA, repeated measures ANOVA.
يعني هذه الداتا عندي وجيت بسوي بدل ما اروح اسوي عليها انوفا مثلا ولا مانوفا ولا اناكوفا اروح اكسبت البيرت تيست لانه الاسامبشن حق البيرت تيست تختلف. اجي على طول اسوي كومباوند سيمتري از ترايل.
يس
رن. اذا كانت الداتا كومبليت راح يعطيني انوفا.
Yes, it should be. If you run the mixed, rack mixed with the complete data,
same.
Yes, the result should be the same thing as the GLM, prac GLM for ANOVA, yes. But this is only if you have a complete data. If you have any missing data, likely result would be different. But which one is more? You're going to go with it?
Try. I do one, this one, this one.
Right.
اللي فاز.
Yes, if you're trying to look for differences of variance covariance structure, then you need to just replace this here. The type equal what? You can choose any other one.
UN.
Like UN.
One prac.
Right. Or like the other one, the variance component, VC, or the other one. This is what you need to change. But for UN, because it's unstructured, you have to add just a little piece here of code before you run it, just to remember this. So now this is what we are saying here. We want to produce this compound symmetry. I'm going to copy this. So this is the first model I'm going to produce. So I have to use the same data name, which is
long.
let long. ID is the same one.
Treatment, group
The
treatment.
group, instead of group, I'll put treatment. Instead of time, I
Week.
put week. And then in a model, you have to use what?
Treatment, week, treatment.
Let as the outcome, right? So what the response is? Let. The time would be what? Week. And the subject equal ID, subject equal ID is fine. So this is the first variance, covariance structures that I'm going to use. Dan, you have an issue?
null model.
Hmm? Okay. So now you look at this. You have 100
Yes.
observations, discounting that 1 to 100 by their ID. You have 2 treatment, A and B. How many weeks? You have 4 weeks. So 4 reading, right? So looking at this here, this is tell you the covariance parameters is 2 for this compound symmetric. The subject 100. You have the maximum per subject is 4, that number of reading. You have the number of observation read 400, the number of observation used 400. What that mean?
Complete.
Yes, read, and so that means there is no missing data. Number of observation not used, 0.
Zero.
That means you have a complete data here. So now this is how the history of the model, how it's run into steps. This is a variance, covariance structures with the correlations, and also looking at residuals, looking at what is called, I'm going to explain this later because this is one model. This is the criteria that you're going to use AIC, you're going to use to compare models. The smaller the better. So that means you're going to run your code for each model, and then you're going to pick the AIC for each model, and you're going to compare those AIC to see which one is
Smaller.
the smaller. That would be your model. Okay? So Now, to explain this, I think you know how to explain this because we are already familiar with this finding. Right, so first thing you need to explain what? The interaction, right? So treatment and weak interaction is significant. Huh? Yes, we're going to explain the interaction further. We say that there is a significant interaction between treatment and weak over time. So that means the treatment, they're having an effect on leg over weeks. It's given you different reading over weeks. So that means whether to be randomized to the active treatment or to the placebo, that it does matter because the active may be giving you more reduction in the level. So that's what it tells you the effect. So the next is we still need to, this is only compound symmetry, right?
Yeah.
We need to produce for the other one in order to choose our best model. So the next one is unstructured. Yes.
الداتا اللي طلعت عندي جزء هذا باك AICC minus 2 risk.
Come together. 1-4. Do you have differences in finding?
Yes.
No.
We should get in the same. We should have the same.
Same.
Only نفس الكود.
We should get the same. Maybe هل تغير الداتا عندك؟
لا.
كم هذا كان الريدنج هذا؟
كان عندي الريدنج هنا 100 11 والتريتمنت 2 والويك 4
لا الاي سي يمكن يكون